Hi everyone, my name is Grace, and this is the first video in a series where I plan to work through the AP Computer Science A curriculum. So, first thing I want to start about is why would you even bother taking AP Computer Science A? So, AP Computer Science A is a course offered by the College Board, and it's where you can go and learn the fundamentals of programming and problem solving in the Java programming language. You can develop skills for future study or a career in computer science and other STEM fields. You can also earn college credit. So I actually took AP Computer Science A in 2016 in my senior year of high school, and I had a really amazing teacher named Mr. Lau. And it was my first exposure to computer science, and it was one which actually motivated me to go and pursue it as a major and now as a career. I currently work as a software engineer. So I think that this course does do a pretty solid job of covering the fundamentals of programming. And if you go and take the AP exam in May, depending on how you do, you could potentially go and earn college credit for an entry-level computer science class when you attend college and get ahead of your course requirements from there. So, okay, I think the first thing I want to talk about is about computer science and programming. So, many computer scientists will lament about how computer science is not programming. But a lot of times when you go and first start learning computer science in college, the first CS course you'll typically have is a programming course. So a lot of people will start thinking, oh, like these two are the same, but they're really not. So, okay, if they're not the same, why is it that we always study programming first? So let me take a step back though and first just talk about computer science. So according to Wikipedia, computer science is the study of algorithmic processes and computational machines. Okay, so what is an algorithm? An algorithm is a description of how to accomplish a task. And so this can be any kind of task. So whether it's, say, you're cooking and you're following a recipe, that recipe is an algorithm. If you're making like a peanut butter and jelly sandwich, like the fact you need to take 2 slices of bread, put peanut butter on one of it, put jelly on the other, slap them together, that's an algorithm. And then you have more complicated algorithms, like let's say I want to go and find the word science in a dictionary. Then what I would do is I would go, open a dictionary, and well, there's a few different approaches here, right? One thing I could do is I could open the dictionary and start looking for the word science on every single page from front to end. And I'll just start flipping and flipping and flipping through the pages until I find science on the page. Which works, it's correct, but it's going to take an insane amount of time. And probably what most of us will do is we're going to make like a best guess as to where we think science will be in the dictionary because it's alphabetically sorted. Go and see if we're right, see if we're before or after science in the alphabet, and then go and check the first half or the second half of the split that we made, depending on where we are. And even though that's a really simple algorithm of going and looking up a word in a dictionary, that's actually a really well-established one, and it's actually called binary search. And for sure, whenever you go and study computer science, that is one of the most fundamental algorithms that you're going to learn. And computer science is a really diverse field. So it's going to include stuff like artificial intelligence, computer systems and networks, database systems, human-computer interaction, vision and graphics, etc. And one thing which connects all these different fields in computer science is that all of them use algorithmic thinking, which is the idea of solving problems and expressing the solution of a problem as an algorithm. And so we study programming not because it's the most important aspect of computer science, but instead because it's one of the best ways to explain the approach that computer scientists take to solving problems. And so we express these algorithms, right? The way that we solve problems in computer scientists, we express those as computer programs. And writing these computer programs and learning a bit about algorithms is what this course is about. So because we're also going to be having a course about computer science and programming, we should also go and talk about computers. So if you look online, a computer is just sort of something which computes. So okay, there's the idea we have in our head of like a laptop or computer. This also includes a calculator. GPS is also a computer then. A toy, like one of those like programmable toys that maybe your niece or nephew received, that is also a computer. And actually, once upon a time, we also, before we had electronic computers, we often referred to humans as computers. In NASA's space program, there were lots of computers, mostly women, who helped with doing complicated mathematical expressions and calculations that were needed to go and send a person to the moon. But for our purposes and in computer science, when we say computer, we usually mean a universal computation device that can be programmed to execute any algorithm. And whenever you go, and so if you were to go and study computer science formally, you might actually, this could range from not just your laptop or your PC on your desk, but could also be like mathematical models. But for now, we're just going to stick to like your laptop or PC. And so on your computer, you have your hardware, which are the physical components of your PC, which includes, say, your CPU, the central processing unit, which is the brain of your computer. You also have the hard disk and your random access memory, or RAM, and these make up kind of like the memory of your computer. But aside from the hardware, the physical components of your computer, you also have the software, which is the computer programs that are on there. This includes your web browsers, this includes your video games, programs that you write, and also the operating system. You might not realize, but the operating system is actually software. Somebody wrote it and put it on your computer, and it's a key software which bridges you, the user, to the computer hardware. But anyway, so here on the software side with the computer programs, that is what we will be studying. And so the study of computational devices and computers in general is a really key branch, though, overall of computer science. So let's talk about the process of programming. So code is this term we use to mean either program fragments or the act of programming. So we can say, oh, hey, there are these 4 lines of code. We can use the verb of like, hey, let's go and code up that solution. And so what you do is you first write a program and then you execute it. And program execution just means the act of having the machine go and carry out the instructions that are contained in the program. So okay, that's kind of what programming looks like, but how do you actually go and write it, and how does the computer understand it? So we write programs in programs languages like Java, but computers actually don't understand Java and other human language. Computers really only understand their own language, which we call machine language. It's made out of binary numbers, which is just a fancy way of saying it only understands the sequences of zeros and ones. So actually, once upon a time, computer scientists who were programming computers would literally go and enter in these sequences of 0 and 1s. But these sequences of 0s and 1s, while they make sense to a computer and they can execute it very quickly, for us humans, they make no sense to us. And it's really, really tedious to go and code in literal 0s and 1s. So instead, we have what they're called these different high-level programming languages. So there's many different high-level programming languages. There's Java, there's Python, there's JavaScript, C, Haskell, OCaml. So there's lots of different kinds of languages that are out there. But for this one, we're going to be looking at Java, which is what we use in this course. And so a high-level programming language, you can almost think of it as like, if the analogy is like to binary numbers like 0s and 1s, high-level programming languages are in human-readable language, like English. And we then, so while we as programmers will go and write our programming languages in Java, which makes sense to us and can be human readable and we can show to other people and will make sense to them, the machine doesn't. So we need something called a compiler, which is also a program. So it was also written by somebody. And this program translates a computer program, which is written in one language to another. And with this, we also need to talk about what an executable is. So an executable is just a program which is written in machine language. So it's a subset of a program, but it's a special term we add for it. So it's a program which can then be executed directly on the computer. So then a native compiler is a compiler which translates high-level languages into machine language, and it creates an executable. So, for example, this is pretty good, but then one problem, and so this is really good when you know what kind of machine you're using, and this is what a lot of people and previous computer scientists used. So one thing or people in general will use. But one thing though is what if you don't, so the problem here is what if you don't know what kind of machine you're using? What if you want to make a program which runs on multiple machines? So what if your thing is on Windows? Is it on Macs? Is it on Linux or Unix? This is something you have to think about if you're using a different compiler. Is your machine 32-bit or 64-bit? So these are all kind of sometimes some issues you might have when you use a native compiler, is that the code that you write doesn't easily go and port from one machine to another or one operating system to another. So this is where Java really, really shines. So Java was released by Sun Microsystems in 1995 and kind of came hand in hand with the advent of the web. And when you think of web, you probably think of a few things. One of the key ideas is this idea of like universal access, right? And this idea that, well, anybody, no matter what machine, no matter what platform, no matter what operating system, you can just go into your web browser and say, go and interact with a web app. And so we want some language and some program which can go and be easily portable, will be platform independent, and that's exactly what Java is. And the way that Java does it is it compiles into Java bytecode instead of machine language. And so Java bytecode, it's kind of like an intermediate level language. It's not a high level language like Java, and if we were humans and we were to go and try to read Java bytecode, it still wouldn't really make a ton of sense to us. But it's also not quite machine language. It's not made out of binary bits with like zeros and ones, so it's somewhere in the middle, so we're just going to call it an intermediate language. And Java bytecode is the machine language of a theoretical computer known as the Java Virtual Machine, or the JVM. And so the JVM is not an actual machine. It's a theoretical virtual one. You can think of it as like this black box which takes in Java bytecode, runs it inside, and then puts out the output of your Java code. And this JVM is what you download onto your actual machine, regardless of what it is. So there's a JVM for Windows machines, there's a JVM for Mac machines, there's a JVM for 32-bit, 64-bit machines, etc. So it's a JVM which runs a Java bytecode file no matter the platform with a Java runtime. And so the Java runtime, it's another program which executes the compiled Java bytecode. And a standard one which is issued is called the Java Runtime Environment, or the JRE. So okay, this is actually some pretty complicated mechanisms going on right here. So the key idea here is basically just know that Java compiles into this intermediate language called the Java bytecode, and you need something called a JVM and a Java runtime to go and actually execute that Java bytecode. And this content here about kind of these inner workings of Java are not important for the AP exam, but they're good context to have as we later on in this video will go and set up an IDE in a Java environment, because you might be wondering, why do I have to go and download these certain things? Well, it's because you need those in order to actually go and run Java programs. So let's now kind of conclude and talk about like these takeaway traits about Java. So from the previous slide and what we talked about so far, we know that Java is platform independent. It doesn't matter what operating system that you're using and stuff like that, Java's compatible. And it's also portable. For example, if I were to go and write a Java program, I can go and take my Java program and hand it to somebody else, and they can go and easily take it and run it on their machine. So it's very portable between different people. Which can also and also these two ideas, platform independent and portable, these two traits can kind of probably start to make a bit more sense as to why Java was really important for the development on the web. And Java is also a high-level language, so it's one which is human readable. And there's some other traits. So for example, Java is relatively simple to learn because of it being a high-level language. It's object-oriented. And so object-oriented is a term which right now doesn't make a lot of sense, but it's really actually important overall. And it's something which we will be talking about in this course. So stay tuned and don't worry about not knowing what that means right now. Java also has a bunch of libraries. And so libraries are pre-written software components which you can use off the shelf. And so some examples of tasks which are easily completed by library components include, say, connecting to a site on the internet, drawing a graphical user interface, retrieving data from databases, or performing complicated mathematical computations. So libraries make it really easy to go and do some otherwise like complicated but common developer tasks. And also, Java is well documented, has a huge developer community. So if you're ever getting stuck, there's probably like millions of people on the internet who will go and be able to help you out. Or it's someone who's probably had that issue before and you'll find an answer and a question to it on like Stack Overflow. And also, lastly, there's lots of job opportunities in Java. So if you go and you take this course and you gain some mastery of Java, it's something which can translate into real-world valuable work experience. And so, for example, I actually work in Java. I work in back-end web services, so Java is a really important language which I use every single day. So, okay, that's kind of it for the introduction. And let's now hop into talking about using the IDE and the code editor. So what is an IDE? I've used this word before, and it's an integrated development environment. And so when we actually go and program Java, we need like an environment to go and program in. And this can range from an IDE to an online editor, so say like a website online with like a REPL, or text files, where I can literally just go and put into a text file. That's also a valid way of programming. But probably when you actually go and work in the real world, and when you ever go and like start working on like more complicated Java programs, an IDE is the best way to go. So I'm going to go ahead and try to work through how to set up an IDE. I believe that the college recommends using Eclipse, so I'm going to go and follow that. And as a fun fact, I've never actually used Eclipse before, so this is also going to be a first time for me. So the first thing that we need to do though is we need to go and set up a JDK. So we're going to do this together. So you can just go and look online and look for a JDK. And so go into this link on Oracle, so it's oracle.com, and the Java SE downloads. We're going to look for here, this Oracle JDK, this JDK download button. And so here you're going to see there's a bunch of different JDKs. JDK stands for Java Development Kit, by the way, depending on what operating system you have, say like Linux, Mac, or Windows, and also what bit type. So here are all like the 64 bits. So since I have a Windows 64-bit machine, I'm going to download this one. I've accepted it. So okay, now that it's downloaded, I'm going to go and allow it to make changes. Wait for it. Now it's installing. So okay, and now we have the JDK downloaded. So the next thing I want to do is I'm going to go and download Eclipse, which is the IDE we're going to be using. So I'm going to look up Eclipse. I'm going to download. Okay, so I believe that I want to go and download the Eclipse IDE for Java developers. To go and do this, all this looks great. Let's install. And also notice that in this Java 11 Plus virtual machine, I automatically found that JDK which I downloaded earlier. Now we just sit and we wait. Okay, cool. So now I have Eclipse set up. So I can go and create a workspace. I'm just gonna call mine APCS. So it's gonna create a folder called APCS on my directory. And I'm going to go and do this in launch. I don't need these anymore, so I'm going to go ahead and close that. Okay, cool. So there's a bunch of different options here. I'm just going to go ahead and just go and create a new file. And so I'm going to go here. I'm going to hit new. I'm going to hit, I want a new Java project. So I'm going to say I want a project name which is called Hello World. I'm going to use this JRE. And so this project name will probably be given to you, like maybe we would use it for like different assignment names, could be like project 1 or something like that, but for now we're just going to use Hello World. We're going to hit finish, and then we're going to create a new module. So I'm going to call this hello.class, or actually I'm going to skip creating a module for now. So, okay, now I'm going to go and create. Okay, that took a second. Okay, so now I'm here. Just like a regular donate thing. So, okay, so now I can right click my package and I'm going to create a new class. So I'm going to call my class Hello World, and I'm going to call it hello, and I'm going to include the public static void main. I'm going to hit yes on this. So okay, now I have this public class hello and this public static void main string args. I'm also going to quickly zoom in so that my code is easier to see. So, okay, now it looks like we have Eclipse all set up. So let's hop back to the slides for a second. And actually, I think something which is better that I would like to do is I'd like to put half on the screen like this. Okay, perfect. So no matter what so right now we set up a Eclipse IDE, but no matter which kind of environment that we use, it's always, writing a Java program is always going to include the same 3 basic steps. We're going to type the program as a Java class, we're going to compile the program file, and then we're going to run the compiled version of the program. So a file is like the basic unit of storage on most computers, and every single file has a name and a file extension. So for example, image.png has the name image, and it has the file extension .png. And so similarly for Java programs, they should always use the file extension .java, and all Java bytecode files are going to use the extension .class. So here, for example, so in an IDE, it does a lot of things for you. So say I now have this new class file called hello.java, so it's my Java file, and knows how it's saved with the extension .java. Also, by convention, all classes are will have a capitalized name, and so similarly, the file name must always match the name of the contained class exactly. So say if this was actually called lowercase hello.java, there would be an error. So okay, let's go ahead and try to go and code our first Java program. So I'm going to write some stuff on here, and if you're following along, I want you to go and copy what's exactly on the screen here into your environment, whether it's an IDE you're using, an online editor, or just a text file. So I'm going to type system.out.println with these parentheses. I'm going to use quotation marks, and then I'm going to say hello world with an exclamation mark. I'm also just gonna get rid of these spaces here because I don't particularly like them. But the Java program will be fine without it. So I have public class with a capital hello and these brackets surrounding. I have these indents here, and then I have public static void main string bracket args bracket and then system.out.println hello world. And there's a lot of things here that you probably don't really understand, but for now, and I know this isn't very satisfying, we will dig into all these later on, but just think of this as like some incantation that you're going to just follow, and when you follow this magical incantation, things are going to happen. Just follow this public static void main string args and the content in here. So okay, now that we have this, we're going to go and compile and run. So in other environments, compiling and running are 2 separate tasks. So compiling is where you go, as we talked before, from this Java program into the bytecode, so the hello.class file. And then running it is then where you take that class file and you execute it. So in a lot of IDEs, they have them together. So we just have like this run function together. But if you're not using an IDE, and you don't see some one button, it's because it's going to be 2 different steps. So okay, we wrote this out. Let's go ahead and run it and see what happens. So okay, we see now here at the bottom this hello world and this console. So what exactly is a console? So a console is a special text-only window in which Java programs can interact with users. And so sometimes you can actually have your console take input from the user, and that's called your user input. But this here is called the program output, and it's the text the computer prints out to the console as a result of executing the program. So when this program that we wrote here was executed, it printed out hello world. And we'll be able to do much more interesting things in the future besides just printing out these words here on the screen. But for now, this is your very first Java program, so congrats on making it this far. And I'm going to end this video here, and I'm going to go and upload another one where I walk through the same, or trying to set up Eclipse on a MacBook as well. And so if you have any questions or issues with it, please feel free to reach out to me, either as like a comment on this video, or you can reach out to me on Twitter at WriteYudon. So okay, that's it for today. Thank you all so much.